This is the Raspberry Pi. What a truly amazing piece of hardware. On this tiny board is packed everything that you'll need to make a personal computer, a home entertainment system, a security system, a gaming system, an Amazon Echo clone, a Google Home clone, and much more. The possibilities are endless. Hi, I'm Leah Sam. I'm an electrical engineer, professional software developer, and university instructor. But most importantly, I have been playing around with the Raspberry Pi since its inception in 2012. Along the way, I have learned quite a lot. Now it's time for me to share all of that information with you, to bring you tips, tricks, and hacks to make you more productive on your Raspberry Pi. I've packed years of experience, trial and error, and research to bring you the very best information for this course, which is the ultimate guide to Raspberry Pi. Here's a look at what the course will cover. We first get into the hardware components that you will need to set up your Raspberry Pi, and I will show you how to connect everything up. We then dive into SD cards, where I will show you how to easily flash and prep an SD card for any operating system for your Raspberry Pi. We then go on to talking about how to configure your Raspbian install, and I will show you the different ways you can connect remotely to your Raspberry Pi. We also get hands-on with the terminal, where I will show you a multitude of Linux commands and tips and tricks to be productive. The fun then begins with GPIO pins, and we will connect several circuits, and you will see how we can use Python to programmatically send outputs, take readings from sensors, and build interesting circuits. Along the way, we will be learning some Python, which is the programming language of choice for the Raspberry Pi. We then delve into working with USB webcams and the Raspberry Pi camera module. We will see how you can programmatically take pictures and video so that you can embed these capabilities into your Internet of Things projects. We then tackle a few fun projects like building an Amazon Echo clone. I will walk you through how to do this step by step. Alexa,
yes.
What is Falcon Heavy?
Falcon Heavy is a reusable super heavy lift launch vehicle designed and manufactured by SpaceX.
And much more. No previous programming or electronics knowledge is required for this course. I will teach you everything you need to know from scratch. If you heard about the Raspberry Pi and want to learn more and see what it can do, or you just want to have a deeper understanding of the Raspberry Pi platform, take the ultimate guide to Raspberry Pi. This is the course for you. Check out the free preview lectures, and I can't wait to get started with you. We're going to have a blast. See you soon. The Raspberry Pi is a small single-board computer that was developed in the UK by the Raspberry Pi Foundation in order to promote teaching of basic computer science in schools and developing countries. It is very inexpensive, and with the latest model for only $35, you can get an entire computer on a single board complete with Wi-Fi and Bluetooth functionality built in. Since the release of the first version in 2012, the popularity of this board, especially in education, has skyrocketed. So, what can you do with a Raspberry Pi? You can install an entire operating system and use it as a fully functioning computer, allowing you to edit documents, surf the internet, program computer software, and use it as a day-to-day computer. It runs a variety of Linux distributions, with Raspbian being the most popular, which is what we will be installing in this course, and it even has a Windows distribution, Windows IoT Core, which runs on it. Okay, great. You may say, but what exactly can you do with it, you may ask? Well, because of the GPIO pins, which provide the ability to connect and interface with external sensors and electrical components, it can be used in robotics and prototyping projects. You can also use it for home automation and industrial automation. You can also set up your own gaming system to play older Nintendo, Super Nintendo, Sega, PlayStation games via emulation software, and you can set up a media server to stream and play your digital movies, music, and online content. The possibilities are endless, and we will learn some of these applications in this course. Now, let's take a look at the Raspberry Pi 3 Model B, which is the model we will be using for this class. You can certainly do the class with earlier models, but you'll need a Wi-Fi dongle to get connected to the internet with version 2 models and earlier. Alternatively, you can use a hardwired networking connection via an RJ45 networking cable. The earlier versions will also not be as fast as the version 3. Here is a rundown of the Raspberry Pi version 3. The CPU uses 64-bit quad-core architecture and runs at 1.2 GHz, and this can be overclocked. It has a 1 GB of memory. It has 4 USB ports, which enables you to connect to peripherals like a mouse, keyboard, microphone, and speakers, etc. There is an HDMI connection, allowing you to connect to a monitor or TV for displaying content. It also has built-in Wi-Fi and Bluetooth capability, allowing you to easily take your projects into wireless mode. It also has an Ethernet port to allow connections to traditional RJ45 network cables for wired connectivity. There is a 15-pin MIPI camera interface connector that can be used with a Raspberry Pi camera. There's also an analog audio port that works with a 3.5mm jack. And it has 40 GPIO pins, or general purpose input-output pins, that can be used to interface with your electronic components and sensors. A power connector is also present, as it requires 5 volts to operate. And it also uses a micro SD card slot, which is the onboard storage. The SD card contains the operating system. We will be talking about how to get this all prepped and loaded to run your operating system. That is quite a bit of power and functionality on a single board for only $35. So now that we have an idea of what the Raspberry Pi is and what it can be used for, in the next few lessons we will look at how we set everything up. The Raspberry Pi 4 was recently released, and this is the latest addition to the Raspberry Pi family. Let's take an in-depth look at the Raspberry Pi 4 so you'll understand the new features of the hardware. At the end of this video, we will also compare and contrast the Raspberry Pi 3 and the 4 so you'll understand the differences between the two boards. The very first thing you should be aware of is that there are 3 options when it comes to the amount of RAM you can have with the Raspberry Pi 4. The versions available for you to choose from are the 1 GB, 2 GB versions, and a 4 GB version. In addition, there have been some changes to the HDMI ports in the Raspberry Pi 4. It now has 2 HDMI ports, and they both support 4K displays, so you can connect 2 4K displays at the same time to a Raspberry Pi 4. These are micro HDMI ports, so the HDMI cables are a little different from the standard HDMI cables. The power port is also different in that you now have a USB-C type power supply connection that you need to make. A good quality 2.5 amp power supply should be used for the Raspberry Pi 4. The Pi 4 now comes with gigabit Ethernet support and has onboard wireless networking, of course, and Bluetooth capability. It has also upgraded USB capacity and now has 2 USB Type 2 ports and 2 USB Type 3 ports. The USB 3 ports transfer data up to 10 times faster. The processor is a Broadcom quad-core processor, which is 64-bit and clocks in at 1.5 GHz. This is of course the fastest processor to date on the Raspberry Pi family. So let's take a look now at the differences between the Raspberry Pi 3 and the Raspberry Pi 4 to see how these two pieces of hardware stack up against each other. First, the Raspberry Pi 3 has a 1.2 GHz quad-core 64-bit processor, while the Raspberry Pi 4 has a 1.5 GHz processor, so a little bit faster here. From a memory perspective, the Raspberry Pi 3 only comes in a 1GB version, whereas the 4 has 3 options: 1GB, 2GB, or 4GB. From an Ethernet perspective, the Raspberry Pi 3 has 100 base Ethernet, whereas the 4 has support for Gigabit Ethernet, much faster networking capabilities. Raspberry Pi 3 has 4 USB Type 2 ports, whereas the Pi 4 has 2 USB Type 2 ports and 2 USB Type 3 ports. From a display perspective, the Pi 3 has 1 full-size HDMI port, whereas the Pi 4 has 2 micro HDMI display ports with 4K support. Finally, from a power perspective, the Pi 3 has a micro USB power source, whereas the Pi 4 has a USB Type-C power support. So there you have it. The Raspberry Pi Foundation continues to upgrade and improve various versions of the Pi, and if you're starting this course, I would highly recommend you buy a Raspberry Pi 4, as that would give you the best performance, and you can also utilize the new hardware features to build very robust projects. Throughout the course, I'll use both a Raspberry Pi 4 and a Raspberry Pi 3. But all the projects and activities can be done with both. Now let's talk about the various components that you're going to need for a Raspberry Pi. For those who are beginners to Raspberry Pi, this would be a discussion on everything you need to get your Pi up and running. And for those experienced veterans, you can feel free to skip ahead for this lesson. So first, of course, we're going to need a Raspberry Pi itself. I am using the Raspberry Pi 3 here, but of course you can use any version of the Raspberry Pi that you may have available. Next, you also need a power supply. So this is a 5-volt power supply with an adapter that you plug into your Raspberry Pi. That's needed to provide the power needed for the Pi to operate. You'll also need an HDMI cable, and this can connect to a monitor and will enable you to see the output of the Raspberry Pi on a screen. Alternatively, if you don't have an HDMI monitor, another option is an HDMI to VGA cable. So this end can connect directly into the Raspberry Pi, whereas the other end, as you can see, is a VGA connection, and this can connect to your VGA monitor. So this is a handy component if you don't have an HDMI monitor, and I'll put a link to this in the resources for the video. Next up, we are going to need an SD card, and of course we have to flash this first and prepare it with the operating system for our Pi. In order to access the SD card, we're also going to need some type of SD card reader. So a couple of options. You have this SD card adapter that you could insert your SD card in here and then insert this into your laptop or PC to access the SD card. Or an alternative version is this USB fob, where you can insert your SD card into here and then insert this into a USB slot to access the SD card. Next, you'll need a USB keyboard and a mouse. As you can see here, I have a keyboard and a mouse that's combined in one, and it is wireless and works via a USB connection. So I just need to plug this into my Raspberry Pi, and by just using one USB port, I'm able to have both the keyboard and the mouse. Alternatively, if you have a separate USB keyboard and mouse, that would work fine as well. So there you have it. That's all you need for your Raspberry Pi. And of course, in addition to this, you would need a monitor that you would connect the Raspberry Pi to in order to display output. But those are all the components that you'll need to get your system up and running. So I get asked this question quite a lot from a lot of my students. I just got a Raspberry Pi and I don't have an extra keyboard or a monitor or a HDMI cable or a mouse. How do I set it up? Well, this actually is a fairly straightforward process, and it's known as setting up your Raspberry Pi in headless mode. So you can use an existing computer or a laptop, and if you just have a Raspberry Pi, you can get it set up pretty quickly. And we'll look at the process of how easy it is to get your Raspberry Pi set up in this way. So what are you going to need? Well, first, a Raspberry Pi 3 or 4. I'm going to be doing the video with a Raspberry Pi 4, but you can use a Raspberry Pi 3 as well. You'll need, of course, a 5-volt power supply for your Pi and a micro SD card. You can use an 8 gig, a 16 or 32 gig. 32 gig would be preferred, but 8 gig can work. And of course, you need to have a micro SD card reader. That's how you're going to insert the micro SD card into your laptop or your computer, and you're able to access it and actually flash it and so on. So next, of course, you're going to need an existing laptop or desktop computer and a wireless network connection. So this is the bare minimum that you'll need to get your Raspberry Pi set up in headless mode. So what does the process look like? Let's take a quick overview of what will be involved. So first, you're going to flash your SD card with the latest version of Raspbian. And once that's done, before we actually boot it up, we'll need to create 2 special files on our SD card. So these files will be created at a root level, and they're called SSH and WPA_supplicant.conf. And this file is actually the wireless configuration, or I should say the configuration that you'll need to connect to a wireless network. So we'll see how to do that and walk through those steps. Next, we're going to boot up our Pi, and we have to get the IP address of our Pi. So there are many different ways that you can do this, and I'll talk a little bit about the different approaches that can be used. Next up, of course, once we have the IP address, we are going to connect via SSH, and we need to enable a few configuration settings in the raspiconfig settings tool, and those would be enabling the VNC viewer, booting to your desktop, and setting the screen resolution. So we'll walk through this process. Finally, when you get all of this done, you can reboot your Pi and use VNC Viewer to connect to your Pi, and you will be in. So that's all that really is involved, and we are going to go through these steps in detail. At the bottom here is a link that can give you a step-by-step guide on how everything is done. So if you take a look at that link, here you'll get the step-by-step details on what you need to do and all the configurations that you need to make. But now we're going to walk through this process step by step.